Hello again, and welcome to another old steam powered machine shop. If you're new to this channel, this is a shop that I put together to kind of simulate a small job shop of the early 1900s, and they were tasked with maintaining building parts, repairing parts, and maintaining the machinery that was invented in that time period. And so, in keeping with that tradition and being a useful part of the community, I've got a few little jobs here that I've been working on. This is some pins for a backhoe, case backhoe, and they are obsolete parts and they're totally worn out. And on this video I've got some clips of working on these. It's not a complete story of the whole part from beginning to end, but I think you get the idea how we did it. And also got some things from the front shop to show you. So we'll get right to it. Thanks a lot for watching. Got the stock set up in the old Cushman 4-jaw here. Got my indicator set up. And now check it out on the end. A lot of you have commented on this indicator and wanted to know what the story was with it. I kind of featured it on some of my earlier videos, but it was made by the J.H. Boulay Company in Beverly, Massachusetts. The patent date on it here is 1901. Way ahead of its time. so quiet you can hear the tool in the cut. It's something you can't hear in a modern machine. Second pin I gotta make. This is for the lower swing. That high-speed steel tool bit is not like 4140 at deep surface. A little bit of a chip flaker on it. Doing much better. Looks like the main belt needs to get tightened up a little bit. threading the valve rod. That's the long thread on the end with the adjustment screws. Okay, I'm set up to cut 1.5 inch 12 thread with a high-speed steel tool, ground to 60 degrees. Relief is cut here, and the gear set is 12. Let's see, where am I? Right there. 12. This is if you're on the feeds lever, it's 48 thousandths per revolution. Okay, so that's in this column here. The lever is set in that column, and it needs to be BC. C, and come on, focus. B. Start up the engine. Yep. in between setups on the lathe to take advantage of the time and put a little water in the boiler. This is a Metropolitan injector, and the one on the right is a Hancock inspirator. Two different brands, devices to put replacement water into the boiler using the boiler's own steam pressure. And I talked about that in some of my earlier videos. This one is pretty simple to operate. First pulling water through. Starts to inject it. And you shut off the boiler. And if you don't do it in that order, it won't work. Find that out. So both injectors are running at the same time. Hole for a cotton pin. A YouTube creator named of Pete Larson has a channel that's pretty interesting. It's about life on the farm and everything that it involves, and part of that is keeping your equipment in shape. And he is systematically rebuilding a bunch of old tractors that he had on the farm that were his father's or his grandfather's. And one of the heads he sent up for me to work on was Farm All Super C. and I thought it would be interesting for you guys if I videoed little clips of that job from start to finish all the way through the shop. So that's what I'm going to do here. In an abbreviated form, this is the whole job. This is the cleaning oven. You've seen me use this before to heat up cylinders to install sleeves, but this is what it's actually supposed to be used for. The cast iron parts go in here, and we run it at about 670 degrees for an hour. It was in the cleaning oven for about an hour at 670 degrees. Now it's cooled down, it's in the steel shot blaster. I don't have enough electrical service here to run this 10 horsepower electric motor in this shot blaster. The initial inertial load on it to start it is tremendous because it's got a very heavy fan in it that acts like a flywheel. So I run it with my Chevy here. Out of the bead blaster, it looks like this. I'm putting bronze guide liners in Pete Larson's Super C head right in the existing guides. And the way these chambers are really deep, this air fixture won't work on it, so I got to hold the guide by hand. That's okay. This is tapered. This has got a 45-degree angle on it so that it goes right against the existing face of the seat. Lines everything up. I'll just hold a little pressure on it. Particular part number that I buy have a end that's crimped over. They cost you a little bit more, but it's easier to get them started. Trim it flush with the seat, or with the guide, the end of the guide. I don't know if you can see it. These are the ball broaches, a different size, and this is one that's designed to take them out. If you ever have to replace them, or you screw one up putting it in, this thing cuts it just like a can opener, right down through the middle, and it gets about 3/4 of the way down in there, and then it catches on it and pushes it out the other end. It's really an amazing tool. Okay, 11:30 seconds. I know from experience which one I'm going to need. Probably is going to be this one right here. Over. Trim the top side. You can see these seats look smooth, but they're very, very wide, like a bald tire. Way too wide, and that's from wear or subsequent valve jobs without doing the 30 and 60 degree angle on the top and the bottom to narrow the seat. But they're not burned too bad. This one is probably the worst one. It's a little crusty here, but not like you usually see them. That one should do it. This is a truing stand to true up the wheel. And in this shop, everything is ground the same. 45-degree seats get 45-degree seats and valves, no interference angle. So this is set at 45 on the scale here. Oh, that one ain't working at all. I'll try a different kind of stone. This is a pink type stone, and different types of seats and different types of cast iron grind differently, take different style stones. Has no seats in it at all. This is just ground into the cast iron, so I'm going to try a white stone. Okay, I got a gray stone in there. This is considered to be a general purpose stone. Much better. Now I think this camera angle is a little bit better. Okay, this is a 30-degree stone that cuts the top edge. Just hit that a little bit. One more with a 45. And with a 60. Okay, I've hit this several passes with the 45 and several passes with the 30 and 60, and you can see the three angles there and see how narrow the seat is now, and that seat matches up on the valve face about 3/4 of the way up on the face, so that's exactly where you want it. So this valve seat's done. When I've got the angles about right, I just take a magic marker and you can see there's the front of the face right there. It's back from the tip, from the edge, and it's about the right width for this engine. And it's all the way around, so that lets you know you're pretty concentric. You can check it with a dial indicator. Like this one. And check the concentricity. But if you got a magic marker print on it like that, you're going to be within 1,000. So it's a time thing. It takes a lot of time to grind seats rather than cut them with a 3-angle tool, which I think is, the grinding is much more accurate. Although it takes more time, I think it's worth the trouble. And of course, some of the kind of things you have to deal with. I ordered 00313 intake valves, and I got 00312s, which are the exhaust valves. So a couple more days to get the right valves, send the wrong ones back. Part of the job. The rockers on Pete's engine have got divots worn in the end that touches the valve stem. So here's a little jig to resurface those. About got it. This is one of those deals where just about every job that comes in here has got a broken off stud somewhere that you have to deal with. And this one is right there. I use Kano coil penetrating oil, and of course now I can get to both sides of the piece on the top and the bottom. And I usually select a drill that gets it about a little more than half the diameter of the bolt. Well, you got to know when to stop here. I certainly don't want to break that off in there. I wouldn't personally have given you a nickel for trying to get it out this way, but it's plan A, so we pass on through that to plan B. is almost out to the root of the thread. So we'll try to pick it up with a prick punch. Okay, to pick it up here, this is actually plan C and a half, in that I really wasn't sure how I was going to do this, but I picked some of the thread out and determined that these aren't really high strength hardened studs, but they were really rusted in there because water was on the back side of them all the time. So I picked out enough threads to get 3/8 course tap started in the first couple of threads, and then I've got my centering center here holding it straight, and I'm actually cutting the rest of the thread out. Okay, the head's ready to go back together again. These are the new springs, and you can see how the old springs are sacked out. They're about 3/8 of an inch shorter. So I got the retainers on there. Sorry I didn't get any good shots of the cylinder head before it got out of here, but they came to pick it up and was busy. But this is the finished parts for the backhoe, and I got some still shots for you on that. So that's all we got time for now. I got to run. We'll catch you on the next one.